Are agents wrong? Yes, they can be wrong. And then what do we do to prevent that from happening? So we were having a conversation earlier about what do customers demand of companies like Arch, and what do you want out of your AI? You simultaneously want complete data protection, no leaking, nobody training with my data, but I also want you to be a learning system, which if it ever gets wrong, it does get it wrong, will never happen again. How do you do that? So we were talking earlier how do you not train with the data? You do not bake any of the customer's data into the weights. You do not allow data to go outside. It stays on premise in private clouds. It doesn't go to anybody else that can ever train on it, right? Well, given that you're not letting anybody train on the data, how do you learn? You learn from examples and feedback, which you store in memory databases. So agents have goals, they have tools, they have memory. So an agent that's doing quality root cause or planning, in our case, we have a product called Action Manager, and our Opus generation reactive agents see a problem that's happened, quality has happened, it's dropped, a quality issue has happened, and now the agent wakes up and it root causes. Does it ever get it wrong? It genuinely usually gets it right, because we are so good, we're so expert at writing these prompts and understanding the structure of data, building the data foundation that gets it right. But of course, there's a stage at which we're still figuring these things out and it gets it wrong. It says the wrong downtime root cause. Well, I thought it was down because of the machine, but actually it was materials. Or I thought the root cause was this, but it's actually that quality issue, right? And the way that can be fixed is we generate a ticket to our users that says, we understand the root cause was this, and these are the actions that we think you can do. The user is, hopefully it's correct, they just solved the problem. They can give us feedback line by line, thumbs up, thumbs down, of if this is the right thing that actually solved the problem. But they can also click that the whole ticket was wrong, and they can interact with the ticket and say what they actually did to fix it. When that happens, we're getting feedback, also the good feedback. So we're getting all the good feedback that this actually solved the problem, and we're getting the feedback that this wasn't the case and something different happened. More complicated example is an agent workflow that even goes through QMS. So imagine we detect a quality issue or an NCR, non-compliance, say in a medical device factory, and we open a ticket inside the QMS. Then a human still does their normal workflow to actually check if we root caused it. We wrote a description into the ticket. They do their whole workflow, and then at the end of that ticket, we're going to get a copy of that ticket. So that I first described how in Arch itself, we've built a workflow to make sure we always get feedback to collect examples into agent memory, but another database. But also if it's into another system, into a different QMS, PM system, a human is doing the workflow to actually solve the quality problem, document what happened, we're going to get a copy of that ticket. So what initially was thought to be the root cause, what at the end of the day did the human write? And those go into two databases. And now our agent, think about how you as a person would look at it. Well, here's what I thought the root cause was. Oh, looks like it was exactly the same. Oop, looks like it was different. That's interesting. And these become examples that the agent is allowed to check the next time it does its work. Now, again, these examples typically are kept only to a customer, but some customers give us the right to anonymize them when that's possible and use them across other customers. So now these are examples. In AI, this is called, when you have no examples, it's called zero-shot prompting. Just a prompt, 0 shots, 0 examples. And actually, a lot of times AI is right these days with absolutely 0 examples. It gets it right the first time, more than you would think, but not always. And that's fixed by having more examples in the memory database that corrects it. From the user's perspective, this looks like, this silly AI, that's not the downtime. The downtime is this. One example of AI thought it was this, it was this. Next time it runs, AI, I think it's this again. But in the memory, when I picked that, they flipped it to that. Maybe I'll pick this one. And the person goes, yep. And that reinforces it. Not by training the weights, a full reinforcement learning neural net don't have to get involved in that. The model's already smart enough. We just cache examples that are well structured in the ontology. In other words, in the type of problem you're trying to solve, that become queried as part of the prompt. So a lot of technical language there, but I would simplify it to say, if you think about a person, it's like maybe short-term and long-term memory. It's like we don't change the long-term memory, like bake it into the brain. Short-term, the things you can remember. A database of a few specific examples where the factory user told you not that, this instead. Keep that in short-term memory. It's accessed for this exact problem type. When you take the AI to do something totally different, wipe the memory clean and get a new memory that starts. And that's what we find is the best result. Mostly gets it right the first time because of right data, expert prompting, and rapidly fixes a few number of examples is all you need. And the AI is getting it right.